Okay, today what we're going to talk about are dilations. Dilations increase or decrease the size of a figure given specific requirements to create a similar figure. Okay, so remember when we had our larger triangle and our smaller triangle with the exact same angles, those were our similar figures. Well, dilations basically do the exact same thing. Dilations can be factored to create a scale factor. We'll use the following scale factors. These are generally the ones that we're going to use. Multiply by 1/2 or multiply by, you would do 1 divided by 2, 0.5. Multiply by 1/4 or 1 divided by 4 would be 0.25. Multiply by 2, 3, or if your paper doesn't say it, multiply by 4. So let's go ahead and talk about an example of a scale factor of 1/2. So if we have a scale factor of 1/2, all we're really doing is we're multiplying our x and our y, okay, our x and our y terms by 1/2. So I would say 3 times 0.5, and I get my x would be 1.5. 1 times 1/2 would be 0.5. 5 times 1/2, I would say my new b, we call this b prime, okay, that's a prime up there. That basically means our new point that has been created would be 2.5. B is our original, B prime is the point that's been dilated. And 2 times 1/2 would be 1. 5 times 1/2 again would be 2.5, C prime. The x would be 2.5. And then -3 times 1/2, you would just say -1.5. So let's go ahead and see how this actually works. It says graph the triangle at the coordinates. So we have over 6 up to, there's my first point. Over 4 up to, there's my second point. Oop, that didn't want to work out so nicely. There we go. And over 6 up 6. So here is my third point. So here's my really cool triangle. My board's acting a little bit funny. Please forgive that. Okay, so now it says dilate the figure with a scale factor of 1/2. So what I'm going to do is I'm going to multiply each of these values by 1/2. So if I multiply 6 times 1/2, my x prime point is going to be 3. And 2 times 1/2 would be 1. So over 3 up 1. If I multiply 4/2 by 1/2, 4 times 1/2 would be 2. 2 times 1/2 would be 1. Over 2 up 1. And finally, 6, 6. I'm taking this point up here, 6, 6, and I'm multiplying it, each of those values by 1/2. So my new z prime would be 3, 3. So over 3 up to 3. And you can see that I have two similar right triangles. The only difference is my dilated one has become smaller. Now, just like the image getting smaller, my image can also get larger. So let's take a look over here at the examples of using a scale factor of 2. So basically I'm looking at my A point, 3, 1, and I'm going to use a scale factor of 2, which means 3 times 2 is 6, 1 times 2 is 2, 5 times 2 is 10, 2 times 2 is 4. So B was 5, 2. B prime is 10, 4. 5 times 2, once again, that's 10. Negative 3 times 2 is negative 6. So C was 5, negative 3. C prime, 10, negative 6. So let's go ahead and look over here. I have A, B, C over 1 up 2. I'm going to label that A. I didn't do it before because I just wanted you to see how it was happening, but let's go ahead and take this to the next level. All right, what we're going to do is we're going to label A, B, C, and when we dilate them by a scale factor of 3, we'll label A prime, B prime, C prime. So I have B, which is negative 1, 2, and I have C, which is 1, 1. So that was B, and C is 1, 1. And so we have a nice, let me move that A a little bit. So we have a nice right triangle, ABC. So now we want to go ahead and use a scale factor again of 3. Okay, so I'm going to say 1 times 3, that's 3. 2 times 3 is 6. So A prime is going to be over, I'm going to use a different color so we can see, over 3 up to 6. And I'll label that A prime. B prime, negative 1, 2. Okay, so negative 1 times 3, that's going to be negative 3. 2 times 3 is going to be 6. So I have negative 3 up to 6. That would be my B prime. And finally, I have 1, 1. 1 times 3, 3. 1 times 3, 3. So C prime is going to be 3, 3. So I go over 3 up to 3. So my larger dilated right triangle, A prime, C prime, A prime, B prime, C prime, has now been created. Thank you.